Welcome to gradient and angle of inclination. So just a reminder that when we find the gradient of a line, it's equal to the rise over the run. And if we have our 2 points, x1, y1 and x2, y2, the distance the rise is y2 minus y1, and the distance the x value or the run is x2 minus x1. That's how we end up with the gradient formula, y2 minus y1 over x2 minus x1. Parallel lines obviously have the same gradient, so we say that the gradient of the first line equals to the gradient of the second. And perpendicular lines, the product of their gradients equals to -1. Perpendicular meaning that the two lines meet at right angles. So we can use one or two formulas. We can use m1 times m2 equals to -1, or by putting the dividing by the m1, we get m2 equals -1 over m1, or what you'll hear regularly is negative reciprocal. So that means you change the sign and reciprocate the gradient. Collinear points, 3 points, we say that they lie on the same line. And if we can test those 3 points and they have the same gradients between any of those 2 points, then they are collinear. When we look at the angle of inclination, it's the angle that's formed by the positive part of the x-axis and the line that we actually draw. And we have a formula that the gradient is equal to tan theta. So the gradient's rise over run, tan theta is equal to opposite over adjacent, which happens to be rise over run. So that's how we figure it out. If we have a positive gradient, so a line that's got a positive gradient, we always get an acute angle with the positive x-axis. And if we've got a negative gradient for our line, then we will always get an obtuse angle. Now let's have a look at some examples. So we're going to look at a quadrilateral, A, B, C, D, and we're going to show that the diagonals are perpendicular. And then from there, we'll find the angle of inclination of those two lines using the gradients that we found. So for those points, so A, B, C, D is in order around the quadrilateral. So AC would be one diagonal and BD would be the other diagonal. So if we find the gradient of AC using our y2 minus y1 over x2 minus x1, the gradient of that is 3. Similarly, finding the gradient of BD, so we get 6 minus 4 over minus 2 minus 4, and we get a gradient of -1/3. If those two gradients multiply to equal to -1, which they do, then we say that the lines or the diagonals are perpendicular. So now we're going to find the angle of inclination given that the gradient of one is 3 and the gradient of the other is -1/3. And the gradient formula is tan theta equals to the gradient. So tan theta equals to 3. Take the inverse tan and you get 72 degrees for the first one, and take the inverse tan of -1/3 and you get 162 degrees. Thank you.